Okay, good morning, good afternoon, good evening, whenever it is that you're going to be watching this. So this will be the first of 3 lessons where the first session is going to be on just a basic pulley structure. So I'm just going to share my screen so you can see it. Hopefully you should see this pulley system to the left-hand side. And the question would simply start off with the particles shown in the pulley system below are released from rest. Find the tension in the string and the acceleration of the system. But before I do anything, I first of all need to make sure that I've got all my forces drawn on the system. These types of questions are a lot easier once we have a proper force diagram drawn. So the first thing to notice, I've got 2 weights here. I've got 3 kilograms and 5 kilograms. So they're going to have a force acting downwards, which is going to be 3G and 5G because it's going to be their weight, which is impacted by gravity. And because of that, they're also going to have a force acting up on the rope as well. There's going to be some tension force acting up, which would be reciprocated by the pulley as well. So I'd have these tension forces acting down. Just for easiness, I'm going to just label these. So this is going to be box A, particle A, and this is going to be particle B. And before we do any maths, I want to think about what's going to happen in this system. If I release these from rest, what's going to move first? Well, they'd move at the same time, but what's going to move in what direction? So I've got a weight of 3 kilograms and 5 kilograms. So naturally, if I had these together, the 5 kilograms would drop and the 3 kilograms would rise up because this is heavier. So my system is going to be accelerating downwards on the right-hand side, and on the left-hand side, it's going to be accelerating upwards. And that will therefore show which way the acceleration will be moving when I'm going to look at my resolving equations. So I'm going to start off with, I'm going to try to find the tension of the acceleration of the system. So I'm going to resolve my forces around A. So they're going to be resolved vertically. And that would give me, well, what direction is it going? It's going to be traveling upwards. So that's going to be tension is positive, take away 3G, and that's going to be equal to the mass of the system, which is 3, multiplied by the acceleration. And likewise for B, if I resolve my forces vertically, I'm going to get, if I resolve them vertically, the system's going to be traveling down. So they're going to be traveling down. So that means 5G is going to be positive. And I'm going to take away my tension, and that's going to be 5A. So I've got these 2 equations now using my F equals ma. If I add these 2 equations together, so equation 1 add equation 2, well, t add negative t is going to cancel out, and 5g add negative 3g is going to be 2g. So I'm going to get 2g equals 8a. And now 2g is just 2 multiplied by 9.8. So 2 times 9.8 is going to be, I don't know why I'm struggling here. 2 times 9.8 is, 19.6. And that's going to be 8a. So therefore, if I divide by 8, I will get a, which is 2.45. So it is 2.45, and it's meters per second to the minus 2. Lovely. So that's the acceleration of my system. How can I use this to help me to work out the tension? Well, because it's a light and extensible string in this system, I can use this to work out my tension by just assuming my acceleration in both of them would be the same. So I'm going to use t minus 3g is equal to 3a, and I've worked out what a is, so I'm going to substitute it in. So this is looking at equation 1. By substituting it in, I'm going to end up with t equals 3 lots of 2.45, which is 7.35, add 3g. So add 9.8 times 3, and that is going to be 36.75 newtons. And that would be how I would find out the acceleration and the tension in a system with particles in. So I'd encourage you guys to have a go at these questions. I'm just going to scroll down so you can see them. There are 3 questions here. I'd like you to have a go, and that'd be the end of the first session. Thank you.